Hello Year 2, welcome to another one of your maths lessons from home. So like normal, we're going to start off with some fluency. So yesterday we were looking at multiplying by 1 and what happens when we multiply by 1. So remember, you may have noticed yesterday that when we put a number in here, whatever the number is, when we times by 1, our product is always the same. So if I put in the number 7 here, 7 times 1, what will our product be? Super, the product will be 7. So 7 groups of 1 will be 7. What about if I change our number to 14 and I have 14 multiplied by 1? What will our product be? Well done. So 14 groups of 1 would be 14 because the product is the same as the factor that we're starting with. Excellent. So let's go back to our early numbers. Let's go to 0. 0 times by 1 equals 0. That's right, it's the same. If I've got no groups of 1, then I don't have anything. I've got nothing. What about if I multiply by 10 then? So here I've got 0 groups of 1. What about if I have 0 groups of 10? What about if I have 0 groups of 10? Exactly, I've got nothing here, so that means my answer is 0. So we might also work out that when one of my factors is 0, my product is also 0, because if I've got no groups, then I don't have anything, I've got 0. So let's have a look at 1 then. 1 multiplied by 1. Well, that's one group of 1, which we know is 1. There we go. There's our one group of 1. What about if we do that with 10 then? What about if I've got one group of 10? What's my answer going to be? We can see down here, this is my one group of 10. And then the number of yellow counters that I've got all together is 10. Fantastic. There we go. So what I'll do is I'll just keep a little note over here so that we can keep a record. And what we're going to do is we're going to try and spot any patterns that we can see. So we know that 1 times 1 equals 1. And we also know that 1 times 10 equals 10. Let's have a look then. Let's change our number in the box to 2. So there we go. 2 groups of 1. So I need to change this here. So I've now got 2 groups of 1. How many groups of 1 do I have? 2. How many yellow counters do I have altogether? 2. Super. What about if I've got groups of 10 then instead of groups of 1? I've got 2 groups of 10. And if I bring my other group of 10 over here, well, for every 1, I've got 10. So remember, just like we did yesterday, 2 groups of 10. So that means I'm going to be skip counting in my 2s. So I go 10, 20. Excellent. There we go. And let's add that to our list here. So then 2 times 1 equals 2, not 3. And 2 times 10 equals 20. There we go. Let's have a look at a different number. Let's do 3. So 3 times 1. So this time I've got 3 groups of 1. Let's add another one of our groups of 1. That means that all together I've got 3 yellow counters. Lovely, when I've got 3 groups of 1. But what about if I've got 3 groups of 10? There we go. Now I've got 3 groups of 10. Well, for every 1, I've got 10. So that means I've got my 3 fingers to show my 3 groups, and I need to skip count in my 10s 3 times. So we go 10, 20, 30. Super duper. And we're just going to try one more. So what I'll do is I'm going to change that number 3 instead to a number 4. And as I'm writing, so we'll change this to number 4 and this to number 4. As I'm filling in our section here to make some notes, I'd like you to try and work out what it is that the products are for each of our equations. If you need a little bit more time, you can pause the video, but let's go through it then. So 4 times 1, 4 groups of 1. I've got here 4 groups of 1. That means I've got 4 yellow counters all together. But if I then change my groups of 1 into groups of 10 and I start to multiply by 10, I've got 4 groups of 10. So that means I've got my 4 groups and I need to skip count in my 10s. So 10, 20, 30, 40. Lovely. So I'm going to leave that on there. And as I'm adding to our little pattern here, I want you to think about these 2 questions here. What's the same between these 2 equations? This 4 times 1 equals 4 and 4 times 10 equals 40. What's the same and what's different between each of them? Okay? Have a few seconds just to think about what's the same and what's different. Have you had a think? Super. So I'm really intrigued to know what some of the things are that you might be saying, but unfortunately I can't hear you. So you might want to write them down or record yourself saying them and send them in. But you may have said something along the lines of, well, the same. My first factor is the same. I've got 4 groups for both of them, haven't I? So I've got 4 groups, and I might have noticed that in my answer, I also have the digit 4. The 4 isn't worth the same in each one, remember, because here it's 4 1s and here it's 4 10s, but I've still got a 4 somewhere in my answer. And in terms of what's different, well, we know that here I'm multiplying by 1 and here I'm multiplying by 10. And I can see that a 10, remember, is much bigger than a 1, isn't it? It's that next value up where it's now a 2-digit number. It's its own column. So this is 10, this is 1. And then you may have noticed that here is 4 and here is 40. So that when I times by 10, my answer also has a 0 on. So thinking back, 4 groups of 10, well, I know that I've got 4 10s. And if we think about our place value, we know that 4 10s and 0 1s would give us the number 40. So what I really want you to notice here is the fact that when I times by 10, what's happening from that first factor is that it's getting 10 times bigger. So what happens is we have to put that 0 on the end to make our 4 turn from 4 1s into 4 10s. So what's happening is we are adding that 0 onto the end. So let's have a look at these then. So today we're just going to work on noticing that pattern, and then tomorrow we're going to do a little bit of work on understanding why that pattern happens. What happens to the digits as we multiply by 10. So if I know that 5 times 1 is now 5 groups of 1, remember when we multiply by 1, my product is the same as my other factor. So I know that 5 times by 1 is 5. So that 5 multiplied by 10 is, well, I know that it's the same, but it changed by having that 0 on the end. So 5 times 10 is 50. If I know that 6 times 1 is, that's right, when I times by 1, my product is the same as my first factor. So 6 multiplied by 1 is 6. But now if I multiply by 10, that means my answer is 10 times bigger. And I show that by adding that 0 on the end. So if I know that 6 multiplied by 1 is 6, I know that 6 multiplied by 10 is 60. Why don't you pause the video, have a go at finishing these calculations, and then we'll go through them. Super, well done for having a go. So let's go through this one then. 9 multiplied by 1, well, when I times anything by 1, my product is the same as my starting factor. So 9 multiplied by 1 is 9. So if I know that, then I know that 9 times 10 is 10 times bigger. So it has to have that 0 on the end. 10 times 1, so 10 multiplied by 1 is 10. It's the same as what I'm starting with because I'm timesing by 1. And then 10 times 10 is 10 times bigger. So I have my 10, and then I have my 0 on the end, so it becomes 100. And then 11 multiplied by 1, that's right, it's the same, it's 11. And now 11 multiplied by 10, it's not 1 anymore, it's 10. So here I've got to put that 0 on the end. So it's 110. And then 13 times by 1 is just itself. And then 13 times by 10, well, I can see here I'm not timesing by 1 anymore. I'm timesing by 10, so I need to put that 0 on the end as well. So it's 13 with my extra 0 on the end as well. So 13 times 10 is 130. So tomorrow we'll start to look at why that happens. But today we're going to have a look at something, a different way of representing multiplication. So far we've been looking at it represented like this. And we might say there are how many groups? 1, 2, 3, 4, 5. There are 5 groups. Groups of, how many do I have in each group? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So I've got 5 groups of 2. And we've been writing that as a multiplication equation by saying 5 groups of 2 equals, and then we've been calculating our product by saying I've got 5 groups. So that means I'm going to count 2 and 2 and 2 and 2 and 2. So instead of counting them all, 1, 2, 3, 4, which is not efficient, we can skip count in our 2's by saying 2, 4, 6, 8, 10. So our product is 10. So that's what we know so far. I'm going to show you a different way of representing that now. And what I'm going to do is I'm going to take these counters out and I'm going to arrange them in rows and columns. So rows are lines that go across and columns are lines that go down, like this. So I've arranged all of my counters into lines that go across and also lines that go down. And when I show my multiplication in this way, this is called an array. Array. Super duper. So an array is when we have all of our counters laid out in rows and columns. So what this array shows us is that I've got 5 groups of 2. So just like I had before, I can show my groups of 2 like this. There you go, we've got 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2. There we go. But what an array is really, really special for is showing us that actually I could put these into equal groups in a different way. Can you see any other ways that I could group these into equal groups? Super, so you may have spotted that instead of grouping them going downwards like this, I could group them going across in their columns, sorry, in their rows like this. There you go. So what I'll do is I'll just clear that and I will draw it again from scratch so it's a little bit clearer for you to see. So before we grouped them in their columns going down and we had 5 groups of 2, remember those purple lines going down like that. But instead, we could group it in a different way going across in their columns like this. If I group it like this instead, what does this then become? Well, then I would say that I've got 2 groups this time, 2 groups, and inside each group I've got 1, 2, 3, 4, 5. So I've got 2 groups of 5, and we would write that like this: 2 groups of 5. Did the number of counters that I have here altogether change? No, it didn't, did it? It stayed the same. And remember, if I'm calculating my product by counting in 5s, I've got my 2 groups, I would go 5, 10. But I didn't really need to do that because I know that when I calculated it before, it hasn't changed since then. So let's have a look at those 2 ways of grouping it then. This is the first way that we did. We had our counters and we grouped them into their columns like this. And we had 5 groups of 2 equals 10 counters altogether. But then instead of grouping them going down, we also grouped them going across in their rows. And then we had 2 groups of 5 counters, but we still had 10 counters at the end. So I want you to have a look at these 2 arrays and these 2 multiplication equations. And I want you to have a think, what's the same and what's different? And you might want to give yourself some thinking time by pausing the video. Lovely. So you might have noticed, let's start with some of the things that's the same. We've already talked about the fact that our product is the same, isn't it? The total amount of counters that I've got in both of them are exactly the same. You might have noticed that I've got a 5 as a factor here and a 5 as a factor here. So they both have 5 in their factors. And equally, they both have 2, don't they? They've both got 2 as a factor. But it's different because these 2 factors have switched around. What do we call it when we can move the 2 numbers on either side of the operation symbol that we're using? What do we call that when we can switch those numbers around? We did it with addition. It's commutative. Commutative. That's right. So arrays help to show us that multiplication is commutative. And what that means is that these 2 numbers here, my factors on either side of my multiplication sign, they can be in any order and I will still get the same answer. Okay, so multiplication is commutative and we can use arrays to show that. So here we go, we've got another array here. So let's have a look. Well, I know that my groups could either be going down in their columns, or my groups could be going across in their rows. So just choose any that you like to start with. I'm going to choose going down. So I've got 4 in that group. So I've got one group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4. So I've got 5 groups of 4. Now I'm coming into a bit of a problem here because I don't actually know how to count in my 4s. I'm not sure because I haven't learnt that yet. So what I'm going to do is I'm going to have a look at grouping it a different way, calculate my product in the way that I know how, and then I will know that this product is the same as this product here, because the number of counters that I've got here do not change. So let's have a look at a different way. Instead of grouping them going down, I could group them now going across. So let's look here. I've got 5 counters in this group. So I've got one group of 5. I've got 2 groups of 5. I've got 3 groups of 5, 4 groups of 5. So I would write that by saying I've got 4 groups of 5. Just realised that I should have written this there. Sorry about that. I've got 4 groups of 5, and I do know how to calculate that because I know that I've got 4 groups, so I get 4 fingers, and each group there is 5. So I say 5, 10, 15, 20. So my product is 20. And here I know that my product is also 20 because the number of yellow counters that I have didn't change when I grouped them. So here you can see that my product is the same, but my 5 and my 4 have switched places between the 2 equations. And that's because I've shown 2 different ways of grouping them. I could group them going down, or I could group them going across. And that shows us that multiplication is commutative. Super, let's have a look at this one then. Maybe you could have a go at pointing at the screen and showing me how you would group these counters together. Lovely, well done for having a go. So let's have a look. I'm going to group them going down first. So I've got 3, 4, 5 counters here. So I'm going to group those together. And now I've got 2 groups of 5. And now I've got 3 groups of 5. There we go. So I would fill that in over here. I've got 3 groups of 5. I do know how to count in my 5s, so I show myself 3 groups and I count 5, 10, 15. That means my product here is 15. What would be the other way that I could group this? Fantastic. So I could also group it going across. So now instead of having groups of 5, I've got groups of 3. So I've got 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, oopsie daisy, 5 groups of 3. There we go. So then I would write over here that I've got 5 groups of 3. Now I don't know how to count in my 3s yet, or you might actually remember from the fluency, but I know that lots of us are still learning and it does take a long time to learn a new times table. So if you are confident counting in 3s, super, you can count your 5 groups and go 3, 6, 9, 12, 15. But if you're not confident counting in your 3s yet, then you should know that your product here will be the same as your product in your other equation. And the product is the same, but the thing that's changed is my two factors are switched around. They're in a different order because multiplication is commutative. Fantastic. So I've got now a multiplication equation, and it's our job to create our own array for this. Now, it can be a bit tricky to draw lots of circles. So what I'm going to do is I'm going to draw an X. I'm going to draw my array using X's. So 5 groups of 6. Now remember, our groups this time could be groups going down or groups going across. So I'm going to have 5 groups, and in each group I'm going to have 6. Or I could have 6 groups, and in each of those groups I could have 5, and that's because multiplication is commutative and I could do it in any order that I liked. So what that means is that going across, I would have 5 to represent my 5 groups. So I've got 1, 2, 3, 4, 5. So there we go. I've got 5 groups there. So one of these going down is going to be a group. One of these going down is going to be a group. One of these going down is going to be a group. And one of these going down is going to be a group. There we go. So in each of my groups, because I've got 5 groups, in each of them, I'm going to have 6 crosses. So this is group 1. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Excellent. So in this group, I've got 6. So that means in this group, I've also got 6. 1, 2, 3, 4, 5, 6. What's the daisy? And then in this group, I've also got to have 6. 2, 3, 4, 5, 6. And then in this group, I've also got to have 6. I do apologise, this is normally much faster when I'm writing on the whiteboard, but it's very tricky to do with my mouse. Hopefully your drawings and representations are much neater than mine. And then in my final group, I've also got to have 6. So what you might actually notice when you do your arrays is that on one of the sides, I will have the same number as one of the factors. So here I've got 6, and you will notice that going down, I've got 6. And then here, my other factor is 5. So then going across, I've got 5 there. Let's have a look at a different one then. So can we draw an array to represent 2 times 4 equals 8? Also 2 groups of 4 or 4 groups of 2. And remember, those groups could either be going down in their columns or across in their rows. So I would have 2 going on the one side and 4 going along the other, and filling that in. Why don't you have a go on a piece of paper or whiteboard and then play the video again when you're ready. Super. So 2 groups of 4 or 4 groups of 2. I'm going to do 2 groups of 4. So what I could do this time is I could say, right, I'm going to have 2 groups of 4 and I'm going to draw them a group at a time. So that's 1 group of 4. And then remember, an array has to be in a nice row and column. It's got to all be very neatly aligned. So this is now my second group of 4. And what I mean by saying that they've all got to be aligned is that I couldn't take these and just draw them down here, for example. They've got to be, like when we do the column method, for example, they've got to be nicely in neat lines on top of each other or directly next to each other. So last time what I did is I said, right, well, I've got 5 groups. So I'm going to have 1, 2, 3, 4, 5 groups. And each one of these was going to be a group. And then I filled each of my groups in with the right number of X's. But this time instead, I said, right, 2 groups of 4. And I did, well, I know that I've got 1 group of 4 and I did it. And then I did another group of 4. And then I filled it in with my other group of 4 as well. Excellent. Now it's time for you to have a go by yourself. So on the circle sheet, you've got some arrays. And what you need to do is you need to have a go at writing the 2 commutative equations that these arrays represent. So remember, you can show that by grouping them going down. So here I've got 5 groups of 3. So I could write 5 groups of 3 equals, or I could group them going across like this. And I've got 1 group of 5, 2 groups of 5, oh, whoopsie-daisy, 3 groups of 5. So I could have 3 groups of 5, and then you can work out your answer. The semicircle sheet is an opportunity for you to draw an array using the following questions. Now you could either draw the arrays like I did here, or if you want to, if you've got maybe some coins at home, or maybe some Lego bricks, or you might have, you could even make your own counters by cutting out little bits of paper. But anything that you've got at home, you could make your own array and put it down on something and then take a picture of it. So it does say draw an array, but you could draw it, or you could make it practically using whatever objects you have enough of in your house. Okay, so then when you've done that for each equation, could you then think of the commutative expression? So here I know that 4 times 2 is 8, so I could have 4 groups of 2, or I could say, swapping these around because it's commutative, 2 groups of 4 is 8. So for each one, could you write that alternative equation as well? And then triangle. So here is a reasoning challenge for you if you feel like getting onto it. There is an array, but unfortunately someone's been a little bit messy and spilt paint all over it. So what you need to do is you need to have a think about what this array could be. So part of the array is hidden. The total of the arrays, that means all the blue counters all together, is less than 16. So what you need to do is you need to draw what you think that array looks like if it didn't have this paint blob on it covering it up. Remember, the blue counters altogether is less than 16, and you can see that it's got 2 counters going down, so it's only got 2 rows. And remember, those rows have to be equal because our equal groups is what multiplication is all about. So once again, the square sheet is now just some missing numbers for you to fill in. So you've got one of the expressions, or you might have parts of expressions, and you need to use the other side of that equal sign to work out which part is missing, which factor is missing. And then there's a problem here for you to solve in as many different ways as you can. So something times 5 is the same as 5 times something. How many different ways can you come up with numbers that can complete that calculation and make it correct? So yeah, well done everybody. That's quite a tricky thing to do, and quite a tricky thing to do as well from home. So well done. I'm really excited to see all the work that you send in. Keep it up. Well done. Bye.